Okay, welcome back. Dr. Matthew J. Traum here. We are continuing to march through how to use the Boothroyd and Dewhurst assembly time estimation process to figure out how to estimate the time for one of my pencil top digit devices, pencil top focus devices. Okay, so where are we? We've got process one, or step one and step two finished, right? I've got the bolt here, the nylon bolt, in my less dominant hand. In my more dominant hand, my right hand, I've got the fidget nut. I've got them oriented and ready for insertion. And so what does that insertion process look like? Well, I do the insertion, and then I need to thread this part on to get it to stay. So what does that translate into? Well, I've got an insertion process. And remember, I've got two different possible charts that I can use from Boothroyd and Dewhurst. I've got my manual insertion chart, and I've got my manual handling chart. In this case, I'm doing an insertion process, so I'm going to get rid of my manual handling chart and I'm going to focus on insertion. And now, really, it's just a matter of sort of reading my way through and remembering what that process looks like and sort of how to navigate this chart. So the first decision that I have to make, which I've already made, is to find my pen. Oh, there it is. Here's my pen. Okay, so I'm going to circle manual insertion just to remind myself that this is the one that I picked. And this is going to be step number 3, right? I like to hang on to these so that I have a record of what I've done in case there's some sort of question or mistake, so I know where that was. Okay, so the first thing I have to decide is whether the part is added but not secured, whether the part is secured immediately, or whether there is some sort of separate operation required once I put the parts together. So what does this mean? Added but not secured, or part secured immediately? A process that is a manual insertion process that is added but not secured means that you basically put the pieces together and they stay that way if you let go and wiggle the parts around a little bit, right? So this, at least at first blush, looks like a part that I've added but not secured that's staying in place, right? So that's potentially really good, except if I, kind of wobble this around a little bit, oh, okay, the part just fell off, right? So let me show you that again. So I put it on there. It looks like maybe, this is added but not secured and it's going to stay in place. But if I rotate it, the part falls off. So I cannot choose part added but not secured because the part does have the potential to fall off if I'm trying to do this really rapidly with my hands. And all I do is just that without the threading process. So my next option is part secured immediately, and that's what I've got. I can do this all in kind of one action, but I definitely have to do the insertion process, and then I have to secure the part by threading it on there. So now I can wiggle this around and flop this around and twist it and turn it and rotate it, and that part's threaded on there. It's not coming off. So I would say that this is a part secured immediately. So let's circle this guy for part secured immediately. And now we have to figure out where we are within this part secured immediately table to get both the first coordinate and the second coordinate in the HI code, the handling and insertion code, just the same way we did before. So I've got to now sort of read my way through, right? So what does it say here? It says addition of any part where neither the part itself nor any other part is finally secured immediately, right? So not finally secured immediately, but screwed on there. It can still kind of travel back up and down. Okay, so that seems reasonable. And then the next option I have here is part and associated tool, including my hands, can easily reach the desired location, versus part and associated tool, including hands, cannot easily reach the desired location, or the tool cannot be operated easily. So if you guys have ever taken apart or put back together a car engine, for example, an old-time car engine, and you have to like reach around the engine to screw in or unscrew something, that's a situation where your vision is obscured and or the tool it's very difficult to fit into the space. There's some space limitations. This is not the case, right? It's very easy for me to see what I'm doing here. Both parts are easily visible. My hands are not in some way obstructed by other pieces of the subassembly. And so it's definitely not that. It's definitely part and associated tool, including hands, can easily reach the desired location. So it's going to be this guy, and that knocks me immediately here to number 3. Okay, so the next thing I've got to do now that I've got the row numbers, I've got to figure out the column number. And so I'm going to read across the top to determine which one of these processes is associated with what I'm doing is I'm inserting the fidget nut onto the bolt. So the first one is no screwing operations or plastic deformation immediately after insertion. No, that's not true because I'm definitely doing a screwing operation. So I'm going to skip that one. Plastic deformation immediately after insertion. No, I'm not plastically deforming the part, I'm screwing it on. Oh, here we go. Screw tightening immediately after insertion. Yes. So this is the one that I'm going to circle. I've now got screw tightening immediately after insertion. The next thing that I need to do now is read down to these two and make a decision. Is it easy to align and position with no resistance to insertion, or is it not easy to align or position during assembly, and or is there resistance to insertion? Well, hey, this is pretty easy, right? It's align, insert, twist, done. So I'm going to circle this guy because it's easy to align and position with no resistance, and that gives me a value of 8. So I'm going to take my straight edge. I'm going to highlight this row. I'm going to highlight this column. And whoops, I'm going to do it a little better so I can actually see it. There we go. Okay, and where those cross in blue, that's my insertion time, 6 seconds. So I go back here. I've got my process number 3, which is an insertion process. Let's do this in black. I don't need to worry about alpha or beta. So this is, I'm just going to write not applicable, because alpha and beta don't mean anything for insertion processes. They're only relevant in handling processes. And now I'm going to call this a 3, 8. 3, 8. And 3, 8 is associated with a 6-second lapse in time to get that screwing process and tightening process completed. So that's going to be 6 seconds. Okay, so what's next? I'm going to take this, I'm going to put it aside so that I can refer to it later if I need to. And I now need to decide what I'm going to do from here. Now remember, this was that kind of point in the process where I could go in 2 different directions. I could either naturally pick up this nut and put it in place and then pick up the pencil and insert it, but that required me then to reach and tighten this down one more time to get it tight, and that is an additional step which I want to try to avoid. Every one of those steps at a bare minimum is going to add an extra second to my process, so I really want to be careful not to add steps if I can avoid them. So I'm going to not grab this nut. The thing that I'm going to grab next instead is the pencil. So I've got this now sub-assembly of the fidget nut and the bolt in my dominant left hand. With my dominant right hand, I'm going to reach out and grab the pencil. Reaching out and grabbing the pencil, that's a handling step, and so I need to record it. So let's go over here. Let's put down H for handling, and let's figure out alpha and beta. So let's set this up, look at it. So I've got the pencil and I've got the sub-assembly here. My insertion, whoa, it's rolling away. My insertion direction is the direction that I'm pointing out with my pen to the left, right? I've got these like this, and I'm going to insert the pencil into the hole. So what's my alpha angle? Well, this pencil, at least the one that I've got here, is symmetrical in 180-degree rotation, right? So my insertion angle, or sorry, my insertion axis is this way. Oops. So an angle that's an axis that's orthogonal to that is into or out of the page. And if I rotate around that axis, that's my alpha. And here's one way that I can insert this guy. And here's another way that I can insert this guy, right? So it inserts that way, and it also inserts that way, right? So it takes 180 degrees of rotation to get from here to there. And so my alpha is 180 degrees. What's my beta? Well, this thing is just circular in cross section, right? So circular in cross section. And this hole is circular. So it doesn't matter how they're oriented with respect to each other. I can rotate these guys any way I want, and one will always insert in the other. And so the beta angle is 0. The sum of those is 180 degrees. And now I can get my code. So we'll move this out of the way. We will remind ourselves that we have two options. We've got manual handling and manual insertion. Which one am I going to pick? Well, this is a handling process. I'm going to put insertion aside, and I'm going to pick manual handling. Here we go. And this is going to be my step number 4. All right. So step number 4 is just reaching out and picking up the pencil. I can reach out and pick up the pencil with one hand. So I circle one hand. My alpha plus beta is 180 degrees, so I'm here, which gives me 0. Is the part easy to manipulate? Yes, it certainly doesn't present any handling difficulties. I can pick it up, manipulate it, no problem. I'm not going to cut myself, burn myself, poke myself, hurt myself. So parts easy to grasp and manipulate? Absolutely yes. Next question, what is the thickness? Well, I'm grasping here, so let's get our calipers ready to go. On, zeroed, measured, 7.3. 7.3 is bigger than 2 millimeters. What about the size? The size is the longest linear dimension. This thing is well bigger than 15 millimeters. It doesn't even fit onto my caliper, right? That's 155 some odd millimeters, and it's still bigger than that. So definitely bigger than 15 millimeters. That gets us another 0, and we are good. This is another really, really good, really, really fast handling process. So I'm going to draw just that row, and I'm going to draw that column, and where they cross and line up, that's going to be my time, 1.13 seconds. So I'm going to come over here. I've got another really fast, whoops, in black, really fast 0,0 process, and that's going to be 1.13 seconds. Okay, next thing I need to do is an insertion, right? Because I'm now holding the subassembly here, I'm holding the part here, and I need to insert the part into the subassembly. So that's going to be an insertion process. I don't need to worry about alpha. I don't need to worry about beta. And I don't need to worry about the sum of alpha and beta. Go right to the chart. So I'm going to move this guy out of the way from my previous step. And I'm going to look back and check to see okay, I've got two options. I've got my handling chart, or I've got my insertion chart. This is an insertion process, so I'm going to put the handling chart aside, and I'm going to focus on the insertion chart. So we'll circle manual insertion, and this is going to be step number, where are we? Number 5. Yep, okay. Step number 5. And I have to decide whether I'm in a situation where the part is added but not secured, added and secured immediately, or whether a separate operation is needed. So in this case, this is not necessarily a press fit. It's not a clearance fit either. It's a pretty tight fit already. So I can insert the pencil into the hole here, and I can rotate this guy. I can shake it. I can even pull on it a little bit, and it doesn't come right out. So I would characterize that as a part that is added but not secured, because I can kind of manipulate this all day, and it's not going anywhere. It's not definitely entirely secured because that lock nut isn't on there, but it's secured enough that I can manipulate this without worrying that the pencil is going to fall out. So I'm going to circle part added but not secured. And that then gets us to this top part of the manual insertion chart. But hey, I just noticed that I've crossed my 15-minute threshold, so I'm going to stop, and we'll pick this up after you guys take a quick break. So go run to the bathroom, grab a drink, and come back when you're ready, and we will do more of this process. See you in a bit.